friends, welcome to free online tech videos. In this video session, my name is Ravi. In this video session, we are going to see about cluster concepts, understanding the cluster concepts. Okay, cluster basic concepts. So how cluster works and what is the use of the cluster and how many types of the cluster we have. All the stuff we are going to see in this video session. Okay, so before jumping into the cluster concept, right, we have to understand that why cluster is required, right? Why cluster is required to set up. Okay, so in this understanding of high availability of the cluster setups, we are going to see, okay, what is a cluster, okay, what is cluster and its types. So cluster is a group of independent servers. So there is a independent servers and independent servers are grouped and interacted through a dedicated network to work as a one centralized data processing resource, which means that the servers, multiple servers, they work as a group, like as a team, one team. So there are different members in the team and they work as a group and they achieve something, right? They maybe achieve some projects assigned to them, or they maybe do some whatever the regular jobs, or some new upgrade projects, all this stuff, right? In the same way, there is a group of servers which going to serve some service without disturbing any disturbance. In the sense, in between there is no disturbance, so it continuously delivers the service to the end users. Okay, simply avoiding a single point of failure. So this, using the cluster, there is no single point of failure. It's that if one point is failed but another point is continuously is working on, then the service will be available to the end user. Okay, but whatever the failure, the administrator can know, but the end user does not know that what is failed. Okay, so there are types, is that the storage cluster are there, high availability cluster and load balancing cluster and high performance clusters are there. Okay, let's go and see this example before building upon a cluster. Okay, so what is there? So there is a standalone server which has typical setup like our NIC card. Okay, this is our hard disk and RAM and CPU. Okay, this is your single power supply and OS, operating system, top of the hardware, and there are some services are running. So the services will be accessed by the end user throughout the internet or firewall and router internal setup or something like this. So this NIC card is going to connect to your network switch, and network switch is and network connectivity is going to be connected to your router, and router connected in between. There is a firewall to provide your security, and the firewall, from here there is a ISP connection which goes the outside of the internet cloud. Using that internet connectivity, the end users can access your services. Maybe the web server, let's say that I have my website is that okay, which is hosted on one of the server, and the server is accessing like this. So in this, if there is any failure of the components in the hardware side, let's example that the power supply is failed, then what happens? Then entire server goes down, then there is no service. If service is available, then you can, OS will be go down, service will go down, and end users say whenever they browse this web service, then it says that the server is not reachable, then they cannot access the server. So to avoid such a kind of stuff, if your business critical applications are running on that, or web server or any applications are running on that, and it's going to be hosted on the public domains, or it's going to be access to the end users, which is business critical for us, then like this kind of setup we cannot run, right? Maybe small organization, it's okay to have some downtime or something like that, but anything, if it is an impression from the customer saying that the customer feel bad about your services and all the stuff, then they are not going to accept, and they remove your service or they terminate your service and they go with the another service, right? So to avoid such a kind of stuff, what we are going to do, Okay, so here there is another standalone server which maybe has a redundant configuration in the sense, so I have multiple NIC cards here, NIC card 1 and NIC card 2. okay, there are multiple, okay, memory modules which is attached, and there are two power supplies, okay, there are CPUs, okay, and there are the hard drives which is binded with the RAID configuration, which means that in terms of RAID times, if one of the disk fails, no problem, because the another hard disk will contain the data, and whenever you replace this drive with the new drive, the data will be reconstructed and your data, there is no loss in the data. Okay, which means that you have all the redundancy component here. Okay, one NIC card fails, another NIC card you have, so this is, you are going to make these NIC cards in the team or bond, okay, teaming or bonding. Okay, then what this will do, so here there is a virtual IP address which is accessing from here, and these two NIC cards under that group. So if one NIC card fails, another NIC card will be accessed from here. So this is the virtual NIC card which is then a master, and these two NIC cards as a slaves for this. So the traffic will goes on like this. So most of the rare cases there is a two network card failures at the same time, but I did not see in most of the scenarios it fails at the same time, but sometime one fails, one remains. Then you can what I can do, you can replace new network card and you can add to the same teaming, then that would be okay, fine, right? So like this in RAID configuration, so one of the disk fails, you can replace the disk and the RAID will be reconstructed and your data will be safe. But what about the motherboard? So in the server there is only one motherboard, right? If motherboard failed, then what happens? So all of these components may not work, or if say one of the service, whenever you are running, the service is stopped, all of the sudden the server is stopped, or service is not able to access, or one of the OS component is corrupted, or one of the folder is deleted from the OS, then your OS went down, then what happens to your services? Then in this case what happens, your hardware is redundant enough to protect your services, but what happens if service goes down, like what of the software services goes down, or the OS component is deleted, or OS component is corrupted, and while upgrading something is happened to your OS, then what happens? Okay, then there is only one motherboard as of now for the most of the hardware components. Okay, there are also redundant motherboards are coming on the new future high-tech systems, but that's going to be in a very expensive systems, right? So that also you can do. Okay, this hardware failure you may be overcome using the multi motherboard component kind of stuff, but that's going to be a difficult for us, and it's not foolproof that it works same like as your server. So this is the things. Okay, question mark is that if one of these components or one of these are failed, then what happens? Again you came back to the same standalone server saying that okay, our components are failed, then we have to replace, we need something like 4 to 6 hours of downtime to do that. Then clients cannot be accessed, your customers are not happy with your service. To avoid such a kind of things, what we are going to set up here, it is that we are going to set up a high availability cluster. Okay, it provides continuous availability of service, which means that there is no, most of the times 99.99% there is no interruption on the service. Okay, maintain data integrity, so data integrity will be maintained on the servers, and node failures, if any one of these in the previous example standalone components are failed or the server is failed, then no interruption to the end users, which means the end users still can access the data, that they can serve, our services can be served to the customers. Okay, how it's going to be achieved? Here are the typical cluster setup which is going to be run. Okay, so there I have web server, I have one more web server, there is a backend database servers is going to be point to these web servers. Okay, and these web servers will be connected with the one heartbeat connectivity to verify that these both the servers are running fine or not. If suddenly one of the server is failed, then this heartbeat is going to tell to the another node or member of the server saying that this server member is failed or node failed, then take over all the components to this, okay, like that. But here is the scenario that you're writing all the things on the storage. Example, say I have web server. This web server, the typical default data is going to be written /var/www/html, right? So this is my web application is hosted, and this mount point, whatever your data is writing, which is not your local drive on your this web server, this is come from your storage. This is came from your storage. The same storage is mapped also here and also here. Then what happens, whenever you are writing the data, you are indirectly writing to storage, you are not writing to this server, okay. In terms of failure of your service or in terms of failure of your component or anything, what happens? So it's going to be switch over your all this data component, what is your critical data is going to be activated here. So this is active passive service cluster service, okay. Active passive, what happens, one server will be active and one server will be passive, okay. So this server is serving the data, but the end users are accessing the data using this virtual IP address. Example, say this virtual IP address is 192.168.2.1 or 2.3 or 2.2, okay. Then this server IP address is 192.168.2.3 and this server IP address is 192.168.2.4. Then what happens if these servers, so if there is no virtual IP here, then what happens, you are pointing your web services to the 192.168.2.3. then what happens if these server components are failed or this server is failed, then the end users have to switch over their IP address to 192.168.2.4, okay. That's a typical scenario. Again, you have to tell the customers to saying that no, this is not my IP address, my IP address is changed because of one of the hardware is failed, you have to switch over to this, something like that, okay. So to avoid such a kind of confusion, saying that I am going to give this IP address to the end user, saying that 192.168.2.2 is my IP address, okay. If these server components are failed, if this service is failed or this server is failed, then still what happens, this 192.168.2.4 is going to be serve the data, but the end users can still access your data using the 192.168.2.2, okay. So how this going to be fed over the cluster service, what it will do is that whatever the component related, like the in this service component and the related associated disks which you have activated in the server, in terms of failure of this node or the disaster recovery happened on this, then what happens, it's going to be switch over from here to here. The mount point, suppose say /var/www/html is going to be activate in the server and web services will be bring up here and the services will be go on from here. So whatever the data is written here will be switch over here, so there is no data failover or there is no data loss. The data is continuously integrated or the continuously protected because of a shared storage. So this is about the typical cluster active passive scenario, how it works, okay. Let's move on and see that how other clusters are set up, okay. So there is a load balancing cluster. This load balancing cluster is going to be set up for rerouting your traffic, okay. Dispatch network service request to multiple cluster nodes, okay. These are going to be an active cluster components, okay. Provide cost effective scalability and failure in load balancing cluster are not visible to the end user. If any failure happen on the back of the node or the server, then the end user does not feel that there is a failure. Only administrator knows that there is a failure. So this is your active cluster configuration or the load balancing cluster configuration, how it's going to be done. So the end users are going to be access your server, but this is going to be a randomly changeover of the user. Suppose say 1 2 3 4 5 6 users are going to be launched onto your web services. What happens is that the first user is going to be launched here, and second user is going to be launched here, third, fourth, fifth, and again the sixth user is going to be launched here, seventh user, eighth user, ninth user, and 10th user. Like this, they are going to be serve the data simultaneously and continuously by requesting the servers to be requested on the multiple things. Like one of the server fails, what happens? The user's switchover happens to the another available server. So this is going to be happen to the servers using your heartbeat connectivity and the load balancing. So these load balancers are smart enough to identify that whether the server is working fine or not. There are multiple criteria you can set up in this environment. Okay, routing the request based on the server CPU utilization or server memory utilization or the server resource availability. All the stuff you can set it up on these cluster settings. So based on that, how the service is going to be rotated on the multiple cluster nodes or the cluster members. Okay, because these all the web servers again connected to the backend databases, then the data will be written to the backend databases. So anywhere if application is accessing same data and end user does not feel that there is any inconsistency in the data, okay, the consistent data will be there and integrity will be there. Okay, your services will be available continuously without any interruptions. And one more setup is that high performance cluster. High performance cluster is used to use cluster nodes to perform concurrent calculations, in the sense continuously. Example, I say that video streaming components. Suppose say if you are watching the video on the YouTube, it's going to be generate a lot of traffic to the servers. Then how the servers are going to be handled? Okay, allow application to work in parallel environment. It's going to be an grid computing. So this is most things. Okay, how I'm going to explain you here. So in the high performance cluster, what they will do is that they have a number of disks, a multiple number of disks. I can say 500,000 something like this disks is going to be combined in that servers. Okay, this is basically used for cluster FS file systems and all the stuff. Okay, like this, there are so many drives in this disk shelves, or the disks are attached to the servers. Then the servers are going to be pump the data, or they stream the data to these servers simultaneously, which means that the workload is distributed to all the servers. This example is that if you have one drive, if you are accessing this drive by the 10 users, okay, it is serving maybe a 10 Mbps speed. Then if the 10 users are splitted into the 500 or 1000 disks, and IO will be very fast. As example, say this is serving 10 Mbps into 1000. What's that? So that is called as a high performance clustering. So it's going to be give you a high performance to the users, end users. They do not feel that while accessing the files there is no latency. Okay, so again we are going to see that how the cluster setups. We already see that high availability cluster. So group of nodes or members, they act like a single system and provides continuous services. We already see this example and the practical scenario how it's okay. And load balancing, active, it scales the performance of server based programs such as web server by distributing end user request across multiple servers. So the end user request is going to be change over to the multiple servers, like as I said that number 1, number 2, something like that. High performance, which is called as an HPC. If client require more IO speed, then HPC is more useful. So like example, video streaming or the news channels or the like kind of stuff you wanted to do a number of files, file uploading, downloading, all the stuff from system generates a more file, log files, kind of stuff you are going to put into that, then it's going to require a HPC kind of stuff. Okay, and one more thing is that storage. Okay, storage servers are is most of it going to be an active components, but it's not load balancing, it's a active components, in the sense at the same time both the cluster nodes are actively participating in availability, and it's going to be give performance, and it's easy to scalable. Like if want 100 TB to be attached to the drives, you can simply attach on the back end and scale your environment, and it's much reliable and reliability provides, and it's going to be give you a good service in prospective of anything. Okay, this is about the clusters and cluster types. Okay, thanks for watching, stay tuned. Please follow us on social networking sites. If you have any technical related questions, you can ask.